Okay, students, can you all hear me? Right. Good evening. Right. Students, in the last session, so for good evening for all of you. So today we are going to conduct second session of organic chemistry reaction practice. Right. So remember, students, in the last session, in the first session, we discussed carbon increasing, carbon atoms increase in reaction number one, aldehyde ketone with Grignard Prejean reaction. And the second reaction we discuss under the special conversion reactions number one. What is it? Preparation of Grignard region. And I gave you two small conversions and I gave you the answers also. So I believe that you tried those questions. Try conversions, okay? So in every week you will have to do some conversions. I'm going to add you new conversions. So let's little by little, let's increase the reactions. Let's little by little increase the depth of the conversions. Let's continue this way, right? So today, first of all, we are going to discuss special conversion reaction number two, right? So write down the topic, special conversion reaction number two. Take out your organic reaction book, write out special conversion reactions number two. Under the special conversion reactions number two, we are going to discuss about alcohols. Alcohols to alkyl halide, alcohols to alkyl halide, and carboxylic acids, carboxylic acids to acid halides, right? Acid halides. So this is the reaction type that we are discussing here. Alcohols to alkyl halides and carboxylic acids to acid halides, right? Remember, students, this is very easy, very simple. What we have to do is, now when you are given an alcohol like R, OH, we know that R group is what? Alkyl group. So this is an alcohol. In order to convert this one into alkyl halide, that means we can easily convert this OH group into a Cl group or else Br, right? In our organic chemistry syllabus, actually they have given three compounds that we can use for this one. We can use PCl3, right? Phosphorus trichloride, or else PCl5, right? So remember, if you use PBr3, you can convert this one into alkyl bromide. So here let me consider PCl3 or PCl5. I can convert this one into RCl. So what is RCl? This is alkyl halide. Understood? Alkyl halide. So in order to convert an alcohol into alkyl halide, you can add here PCl3, PCl5. Then you can convert that one into corresponding chloride compound. If you want to convert this one into bromide compound, we can put here PBr3. So mostly these are the compounds that we can use, right? In the same way, remember students, alcohols to alkyl halides. We know that in carboxylic acid, right? Please mute your microphones. We know that in carboxylic acid we have carbonyl group C double bond O, and OH group is also there in carboxylic acid. So this is the functional group of carboxylic acid. So here also this OH group can be converted into Cl. Here also we can add PCl3 or PCl5. Then this will be converting into RC double bond O C. So what is this? We know this is acid halide. So that means we have started from carboxylic acids. So this is a carboxylic acid. Now we ended up with acid halide. Acid halide. Can you understand? So you can see that this is the functional group OH alcohol. and alkyl halide, chlorine is there. In carboxylic acid, functional group is C double bond or Cl, but you can see that this OH group has been converted into chlorine atom in the functional group C double bond or Cl. Try to understand. So in order to convert this one into OH group into a Cl, we can add PCl3, PCl5, then it will convert into chlorine. And if you add PBr3 kind of a molecule, then you can convert that one into corresponding bromide compound, right? So quickly write down. So put those things in the red color pen, right? Circle everything quickly. Let's discuss few example reactions quickly. Done. Write down few examples with me. Example number 1. Ethanol. Let me take methanol, CH3OH. CH3OH. For methanol, I'm going to add here PCl3. PCl3. Right? So then what is the major product? Major product is CH3Cl. Okay. Students, in your resource book, they have given the byproduct also. When we add PCl3, then the byproduct is H3PO3. H3PO3 when we add PCl3. H3PO3 means phosphorus acid. Just imagine you are going to add here CH3OH and you are going to add PCl5. Then the major product is same, CH3Cl. You can see that this OH group clearly converted into Cl, right? But here the byproducts are, what are the byproducts? So the byproducts they have given is POCl3 and HC when we add PCl5. Okay. So for the first two reactions, I'm going to write down the byproducts in this way because you have to know about these things as well. In your resource book, clearly mention those things. So therefore, quickly write down. This is very important. Right, okay? Right. Then the third one, number 3, third example, we can consider that CH3, CH2OH, ethanol, we can add PBr3, then what are the products? When we add PBr3, products are CH3, CH2, Br. No need to write down the byproducts. Number 4. Number 4, quickly. We have a carboxylic acid like CH3, C double bond OH. So we are adding PCl5. What will happen? When we add PCl5, this OH group can be converted into Cl. For the acidic acid, we are adding PCl5, then it is converted into acetyl chloride. Number 5, benzoic acid. We are adding PBr3. So then what will happen? Benzoyl bromide in this way. Number 6. Number 6. Phenol. Phenol. When we add PCl5, what do you think? Will there be any reaction? Anyone can tell me? Will there be any reaction if we add PCl5 for this phenol? Remember, students, in phenol actually, there won't be any reaction with PCl5, right? This OH group cannot be replaced by chlorine because of the stability of this OH, right? Because this oxygen is actually can give electrons for the benzene ring and it can make a partial double bond with that carbon atom. So therefore it won't break, right? So therefore we cannot consider that there will be any reaction. So phenol is not reacting with PCl5. So likewise, I'm going to give you some special situations in every reactions. So please mark them also, right? Put a star mark and write down phenol. Even though there is a OH group, phenol is not reacting with this PCl5 because of the stability. Let's discuss about this one in detail under the theories. Okay. So here actually our main concern is about the reactions. Number 6, like this. Right. Then what about iodine? Is it not possible with iodine? Yes. CH3, CH2OH. We can do this one with iodine as well. Pi3. Then CH3, CH2, iodine. That's also possible. Right, okay. Are we done? Quickly, yeah? Right. Now let's go for a small exercise. Write down the relevant region that we have to add on this arrowhead. So here, students, we can add PCl, 3OPCl5, and here magnesium triether. And what is the aldehyde we have to add? Now, this is actually a combination of last two reactions, right? So last week, the things that we learn is also added to these reactions now. So what is the newly added compound here? CH2O. So therefore, we can say that carbon, oxygen, and two hydrogens are connected like this. And here we can see this is H3O plus. This is PCl5 again. And here we can add magnesium triether. So here, so what is the newly added region here? You can see that they have put number 1 and number 2. So this is actually Grignard region with aldehyde ketone. So therefore, what is the aldehyde ketone we have to add here, right? So you can see that this is the alkyl group CH3, CH2 came from the Grignard region. Then what are the remaining things? CH3, carbon, hydrogen, oxygen. Then we can put here CH3, C double bond OH. So this is 1, 2. We can consider this is aldehyde ethanol. And secondly, H3O plus is added. We have to do the hydrolysis reaction in this way, right? That's a reaction sequence. Okay, are we done? Quickly, yeah. So this is very interesting. Okay, Pranali. Yeah, if you learn in this way, actually, that is interesting. If you just learn theories, then there is issue, right? Now, in the theory class, we are discussing theories. We know that sometimes we feel boring. Neither. So many theories are there. But if you learn theories along with these kind of reaction practice, organic chemistry will be interesting for you. I'm very sure. Okay. I'll give you some isomers practice also. I will upload some past paper question discussions also. Now, did you see that in the last session we discussed about in theories we learn reaction mechanism number one. So the first reaction mechanism that we learned was what? Chlorination of methane. So you have to repeat it. I told you to write down that one 5 times. Sometimes in the examination you might ask them. So therefore, likewise, let's revise everything again and again and again. Right? When we revise all everything that we learn, little by little, those things will go for our permanent mind. You understand? So then, when the examination is getting closer, organic chemistry will be something very similar, familiar to you. So you can do any question. Okay, right. So the second question, second exercise. Some of the students are thinking that doing organic chemistry is actually 1 week, within 1 day or within 2 days, we can finish everything in organic chemistry. It's not like that. Huh? Organic chemistry is actually a discipline actually you followed in a few months. Okay. So we have an aldehyde. We have added some Grignard region there. Quickly complete this. Then manganese, sorry, Grignard region is formed again. Find out what is the aldehyde we have to add here. So put the correct regions. We have to add down the arrows quickly. I'll do the third one here. So this is very easy. Huh? CH3, OH. So we have a secondary alcohol like this. Third one. Okay, let me quickly go to the second one. So students, aldehyde is given, ethanol. We have to add a Grignard region. So then you know how to identify Grignard region. CH3, CH3 here, carbon, hydrogen. Oxygen is there. Then newly added things are CH3, MgBr. So therefore the Grignard region that we should add is methyl magnesium bromide, Grignard region. Then we know what we have to do. Secondly, in order to obtain the alcohol, we have to do the hydrolysis. For that, H3O plus is added. If you want, you can put here H plus slash H2, right? Doesn't matter. Then here we can add PCl5O, PCl3. And again, they have formed Grignard region, right? So now you can understand how important is this Grignard region. Huh? By connecting Grignard region to aldehyde ketone, we can make many molecules, right? Many lengthiest molecules. And again, this one, Grignard region, they have added an aldehyde to ketone. What is it? CH3, CH3. So this is that bulky group, alkyl group came from the Grignard region. Then this is the aldehyde for ketone group. Definitely this one should be aldehyde because one carbon, oxygen, and two hydrogen from both sides. And secondly, H3O plus is added. And here PBr3. Okay, that's very easy. Right? What about the third one? Third one is even simpler. Magnesium diether. We learn everything last week. CH3MgCl means here we can say that the ketone, no, aldehyde, CH3CH2, C double bond OH. Propanol. And H3 plus is added. Number 3. Quickly. Repeat these things again and again. Automatically, these things will go to your head. So therefore, repeat. Done. Eh? Now let's go for the fourth one. You have to write down these things quickly. Yeah? Go for the reverse quickly. You have to go for the reverse. Number 4. We are adding acetone, CH3C double bond of CH3. H3O plus is added. Number 5. Benzaldehyde is added. The final product is two phenyl groups connected to carbon in this way. Right. So here's the sixth one. Seventh one is also again a combination of reactions CH3OH. Put the relevant compounds in the arrowhead. CH3Cl, CH3MgCl, Let me go to the fourth one. We have to go for the reverse. Let me consider the compound previously we had before the hydrolysis is OMG Br, and what is the aldehyde they have added? C double bond H, CH3. That means ethanol is added. Okay, then the Grignard region should be CH3CH2 MgBr. Then the alkyl halide that we had previously was CH3CH2 Br. Then here in the fifth one, again go for the reverse. OMgCl, CH3. So here we have a propyl group CH2, CH2, CH3. And the ketone that we have added is this one. So we can say that this is the ketone, right? So the remaining things are Grignard region, CH3, CH2, CH2, MgCl. And then CH3, CH2, C, CH2Cl, propyl chloride. Number 5. Number 6, go for the reverse. We have added an aldehyde. So anyhow, the previous product before the hydrolysis should be OMgCl. Now they have added an aldehyde for the Grignard region. So therefore you can see that this is the aldehyde, right? Then the Grignard region should be MgCl. And then initially we had chlorobenzene, right? Chlorobenzene. For the chlorobenzene, they have added magnesium diether, formed the Grignard region containing phenyl group, and they have continued the reaction to produce this kind of alcohol, right? So we have started from chlorobenzene, and you can understand where we have stopped, right? What about the seventh one? Seventh one is very easy. PCl5, magnesium diether, and yes, we have added an aldehyde, no? CH3 MgCl. So therefore, we can say that ethanol, and here PCl5, magnesium diether. So you can see that this is the bulky group came from the Grignard region, right? Then these are the things in the aldehyde. So the aldehyde is the simplest aldehyde. What is it? Methanol, formaldehyde. Secondly, H3O plus is added. And we are adding PCl5. Just now we learned that one. This way. PCl5 or PCl3, doesn't matter. So number 7 is look like this. Right? If you have any doubts, put your doubts in the chat box. Huh? So can you explain the second step of third question, please? Second step of the third one. I erased that one. No? Do you have any doubts in these reactions? 4, 5, 6, 7? Any doubts? Raise your hand who understood the things that we discussed up to now. Raise your hand. Quickly raise your hand. So for the seventh one, CH3 MgCl, it's 2-step. Which one? The seventh one. Ah, yes. I forgot it. Very good. This is number 1. And secondly, we have to do the H3O plus also hydrolysis reaction. I forgot it. Very good. Huh? Because this is directly converted into alcohol. So therefore, we have to put number 1 and number 2 and write. Yes, good. Very good. Number 1 and number 2. Done. Let's go for the next one, number 8. Number 8 is look like this. We are starting from chlorobenzene. Preparing the Grignard region and produce an alcohol like this. Converted into alkyl halide. Again, we are adding compound to produce Grignard region. Then an aldehyde is added. You have to understand what is the aldehyde they have added. Alcohol, right? Complete this one quickly. Wait. We have number 9 in this way. We have to go for the reverse. This kind of a secondary alcohol is obtained finally, but you have to fill these steps and you have to find out the initial compound as well. Okay. Okay, let me discuss the 8th one. Number 8. Magnesium diether is added. Then we can say that we are going to add MgCl is there. CH3, CH2, C double bond H. Propanol. Yes, propanol is added. Secondly, H3O plus. It's compulsory to put 1 and 2. It's compulsory to put 1 and 2. Here PCl5. Magnesium diether. And here we can put CH3, C double bond H, ethanol. Ethanol. H3O plus is added here. And PCl5. Very easy. Right? Check whether you can go for the reverse in the 9th one. Check it. Raise your hand who completed the 9th one. Raise your hand who completed the 9th one. Only Rafa, only Nabil and Laveen. Okay, good, good. Quickly, others also. Very clear. Number 9. What about number 9? So we have to go for the reverse, right? In the reverse, we can say that students, aldehyde is added. So therefore, the previous one should be definitely a Grignard region. Then these are the parts in the aldehyde, CH3 and COH here. And then we can consider then the Grignard region should be CH3, CH2, CH2, Cl, because chlorine is there. MgCl, right? Grignard region. No? Then the previous alkyl halide should be CH3, CH2, CH2, Cl. And before this one, definitely that one should be an alcohol. They have added PCl5, no? So that alcohol again came by adding Grignard region and aldehyde. Yes, that process, ne? So we can say that this is CH3, CH2, OMGBr, CH2, right? So the aldehyde is added for this one. So this is that aldehyde. Then the Grignard region should be CH3, CH2, NgCl. Then this is CH3, CH2, Cl, alkyl halide. So alkyl halide is formed by adding PCl5 for the alcohol, CH3, CH2. So you should be able to go for the revise as well. No? In the examination, they will give you the reverse also. You have to practice the reverse also. Number 9, like this. Quickly come to this one. We have to go for the next one. Done, ne? So is using PCl3 and PCl5 specific phase to piezo, can we use either? It doesn't matter. Zainab, we can use PCl3, PCl5 anywhere in reactions, right? If the byproducts doesn't matter, we can use PCl3, PCl5 anywhere. Now, in these reactions, byproducts are not having a concern. No? So therefore, you can use PCl3, PCl5 anywhere. So as you have put bromine, the previous one should be right bromine, right? Where I have put bromine. The reason that I have choose, yeah. This one should be MgBr. This one I have written as MgBr. Is that correct? No. Because if I write here MgBr, that is wrong. because we have added PCl5 here. Then this is alkyl halide. Magnesium triether is added, Grignard region. Aldehyde is added. Then this one should be definitely MgCl. MgCl. Can you understand? So you can't do those kind of mistakes here. That's wrong. If you put bromine, we cannot accept that one because we have added PCl5 at the beginning. Yes, good. You all know this well, huh? Good, very good. Shall we go to the next one, number 10? Quickly. We have to do 2 conversions also today in the class. Let's see whether you can go for the answers. Number 10, also we have to go for the reverse. Number 10, I'll give you the final product. If not, coming out the answer here. Do this conversion not more than in 4 steps. That means the maximum number of steps that you can use is 4. Do this one, number 11. Right, let's move to the number 10. So here we have added H3O plus, so therefore the previous one should be CH3OMG MgCl, right? OMgCl, and this is the phenyl ring. So they have added methanol, CH2O. So you can clearly see that methanol group, right? Then the Grignard region should be CH3, phenyl ring, magnesium chloride. Easy. Then magnesium is added for the alkyl halide, tertiary alkyl halide. H3O plus. So therefore, here OH, that alcohol can converted into alkyl halide, right? And this is the ketone they have added. You can clearly see that. So the ketone group is like this. Then the other one should be Grignard region. So anyhow, this is CH3, C, CH3, O, MgBr. Then the Grignard region is benzene, magnesium, bromide. And we have started from bromobenzene. Likewise, you should be able to go for the reverse as well. Now try to do this conversion not more than in 4 steps. Maximum number of steps are 4. Yeah, nothing wrong with chlorobenzene. You can use chlorobenzene as well. Doesn't matter. It's completely all right. Anyone here completed the 11th one? Anyone here completed this conversion? Please raise your hand. Anyone here completed that conversion? Not yet. Okay, you have to try, yeah? You have to try this. Right. Mariam, you completed that one, right? Nabil, okay, good, very good. Right. Okay, so some of you have completed the 11th one. Those who completed the 11th one, do the 12th one also. Those who completed the 11th one, do the 12th one also. Number 12 is not more than in 4 steps. Number 12. Please raise your hand who completed the 11th one. Now, Asma, then Gimani, Rafa, Supipi, Sarina, Upeshani, Nuha. What about you all? Eleventh one is a conversion. Nah? You have to go through one step. So the 11th one can be done like this. I'm going to add renal region CH3 MgBr. Number 2, H3O plus. Then we obtain an alcohol like this. Right? Then again we can add PCl5. And again can be converted into Grignard region by adding magnesium diether. And then we are going to add methanol, secondly H3O plus. Then we can obtain this one. So that's a simple conversion. 1, 2, 3, 4, 4 steps. Right. Raise your hand who got the answer in this way. Raise your hand who got the answer in this way. Mariam, Pranali, Rafa, Nabil, Sarina, Rahma, Rihama, Fawaz, Devmi. Good, very good. Then do the 12th one. Raise your hand who completed the 12th one. Raise your hand who completed the 12th one. Okay, good. Mariam is there. Quickly. We have to go for the next reaction. Before we go for the next reaction, quickly complete this one. Right, okay. So the 12th one, done. Now raise your hand who completed the 12th one. Right, okay. Pranali, Asma, Nabil. Right, okay, very good. There are many. So let me do the 12th one. Let me do the 12th one. We are going to add magnesium. Right, MgBr. Then what we can do here? We can add methanol, HC double bond OH. Secondly, H2O plus. Then CH2OH. Then we are adding PCl5. CH2Cl. Again, a green-out region is formed by the magnesium. 1, 2, 3, 4. So raise your hand who got the answer like this. Raise your hand who got the answer like this. Okay, very good. There are many. Yeah, very good. Right, okay, students. Then this is the second special conversion reaction and its application along with the previous two reactions we discussed. Now we have completed 3 reactions. Okay. First one, we discuss about the special conversion reaction number 1. Sorry, carbon atoms increasing reactions number 1, aldehyde ketone with Grignard region. Secondly, we discuss about the preparation of Grignard region under the special conversion reaction number 1. So the second special conversion reaction that we discussed was alcohol into alkyl halide or carboxylic acid into acetic halide, right? So now we are going to discuss about the next one, carbon increasing reaction number 2. Let's see. So write down the topic. Very clear. Write down the topic. Carbon atoms increase in reaction. Reactions number 2. Right. Alkyl halides with potassium cyanide, KCl. Alkyl halides with potassium. Students, this reaction is very easy and you can see that one carbon atom is increasing in this reaction. KCl. Remember, in some past papers, actually, even in the school term test papers, instead of this KCl, they are giving sodium cyanide as well. It doesn't matter, right? But in your resource book, they have clearly mentioned that is KCl. So therefore, we are going to talk about KCl. But in the A-level examination paper, in school term test papers, they might give sodium cyanide as well. Right? So what is the reaction? Right? So the reaction is very simple. We have an alkyl halide like RX. And we are going to add KCl. So when we add KCl, what will happen? This X halogen atom is converted into CN, cyanide. That means cyanide atom came instead of a halogen atom, right? So that halogen atom is eliminated with the potassium. As a byproduct, potassium halide, KX, is formed. Can you understand? So this is the reaction. So you can understand here, alkyl halide alkyl halide simply converting into alkyl cyanide or nitrile group, alkyl cyanide, right? Let's discuss few examples. Very easy. Example number 1. CH3, CH2Cl, ACN plus KCl. KCl is byproduct of CH3, CH, CH3Br. So you can see that chlorine converted into Cn. Adding KCl. That's all. That's all. Chlorobenzene. And students, remember, you can't never converted this chlorine, which is connected to the benzene ring, into any compound, right? මේ බෙන්සීන් එකට කනෙක්ට් වෙලා ඉන්න ක්ලෝරින්ව ගලවනවා කියා හිතන්නවත් බෑ. The reason, students, actually, let's discuss that one under theories. So chlorine actually, with the resonance, chlorine is producing a partial double bond with this benzene ring in this way. So this partial double bond is a little bit strong, right? It's very difficult to break this bond, kind of a double bond. So therefore, because of the resonance stability, carbon chlorine will have a partial double bond here. So therefore, normally chlorobenzene, bromobenzene, like halogen connected to the benzene, cannot be removed from the benzene. So therefore, no reaction. Can you understand? In this way. Right? What about this one, number 4? What about this CH2Br? This is okay because this bromine atom is not connected to the benzene ring. This bromine atom is not directly connected to the benzene ring. So therefore, by adding KCl, this can be easily replaced with cyanide. Doesn't matter. CH2Cl. Number 4. Right? Let me write another example. Number 5. One more example. What about tertiary alkyl halide like this? A tertiary alkyl halide, we are adding KCl and converted into cyanide. That's also very easy, right? By adding KCl, what we have done, we have increased one of the carbon atoms. We have increased one carbon atom in the molecule. That's why this is categorized under carbon atoms increasing reactions. Got it? Carbon atoms increasing reactions. Okay, are we done? Right, okay. Now let's go for the exercise, including this reaction also. Write down exercise. Again, now you can realize the reactions are increasing little by little. Okay, that's why we need the practice. CH3Cl, sorry, CH3OH. Quickly complete these reactions. Number one, very easy. PCl3, magnesium diether. Then we have added aldehyde, HC double bond H methanol, H3O plus, sorry, H3O plus here, PCl5 here, and KCN. So this is the reaction we learned just now. In this way, very easy. Number two, magnesium dry ether, Grignard region. So CH3, C double bond O CH3. Students, remember, if you don't have any theory knowledge, it doesn't matter, okay? You can start to learn organic chemistry from here, right? If any student here who doesn't have any theory knowledge, so I don't have any theory knowledge, I haven't learned organic chemistry before, I don't know anything related to that one. Yeah, now you from here onwards you can start to learn organic chemistry from here, right? So this will give you confidence to learn organic chemistry properly from the beginning, right? So here H3O plus PCl3 KCl. Done. Eh? Let's go for the third one. Third one, I'm going to give you the reverse. Quickly complete these two. ළමයි පුළුවන් නම් මේවා ආයි නැවත නැවත කොලවල ලියන්න. හරි? මේවා නැවත නැවත again and again write down these things in papers. හරි? ඔයගලන්ට අමතක වෙනවා කියලා හිතන හැම වෙලාවකම take out the organic chemistry reaction book and write down reactions, everything. I want to tell you that in your examination, you have to be very careful with the organic chemistry question. The reason that I'm going to tell you is that last 2 years organic chemistry questions are very easy. Okay, compared to the past papers. ඔගොල්ලෝ පොඩ past papers analyze කරන්න හරිද? You have to do the analysis part of past papers. හරි? ඔයා last year papers ටික පොඩක් analyze කරලා බලුවොත් ගිය අවුරුදු දෙකේ, that means 2024 and 2023, organic chemistry essay questions are not that much difficult, right? They haven't given difficult conversions, but in order to do those conversions you need lot of practice. In case conversion එකක් දුන්නොත් ආයි නැති වෙලා යන්න ඉවරයි. If you haven't practiced, done. ඒක නිසා හොඳට practice කරලා යන්න ඕන එකට ready වෙලා යන්න. right? Organic chemistry ඊළඟට එන equilibrium lesson එක තියෙනවා. Equilibrium lesson එකේ දෙන calculations, we are going to do the calculations there. So for those calculations also we did somewhat practice. Ne? We have to be very careful. මේකෙම isomer part එක තියෙනවා, right? Right, third one. I think in your schools, if you know the academic calendar, in that academic calendar, October 17 to November 17, there is a holiday, right? October 17th to November 17th, there is a holiday. That means probably your A-level examination, 2020 A-level examination will be starting from October 17th, I guess, right? But October 17th is Friday, and 18, 19 Saturday, Sunday, and October 20th is Deepavali festival, right? So therefore, probably the A-level examination will be starting from October 21st, Tuesday. We don't know, right? So therefore, you have, so forget about October, will you? You have about 9 months for it, right? So therefore, you have to prepare for that one. Don't worry, still you have time, right? Whatever the level now you are in, it doesn't matter. If you can work hard, right? If you can work hard like a machine in these 9 months, you can change your result in a good way. Okay? If you don't work, remember, no improvement, no result. Can you understand? Then ඉස්සර වගේ නිදි මතයි නිදා ගන්න ඕනේ, right? Tomorrow we have to go for the school, so therefore I have to sleep little bit earlier. Those stories are now not valid. Understood? Only 9 months. If you want to change your result, you have to work. Otherwise, go and sleep well. No results. නේද? හොඳට කියලා නිදා ගන්න ඕන නිදා ගන්න. results නෑ ඊට පස්සේ. වැඩ කරන්න. Work hard. Third one. So in the third one, let's go for the reverse. H3O plus. Here we can add methanol first of all, and secondly H3O plus. PCl3 here. Go for the reverse. I hope that for your examination, they will give you this kind of a flow chart. මම හිතනවා. කලින් අවුරුද්ද දෙකේ ආපු නැති නිසා මට හිතනවා නිකන් ඔයගලන්ගේ exam එකේ they might give this kind of a flow chart. So අනාවැකි කියනවද? නෑ. I just expect, that's all. Number 4. Do the third one and the fourth one quickly. What about number 3? Number 3. Because we have to go for the reverse, right? PCl3 is their previous step. So therefore, we can say that this is alkyl halide, right? Alkyl chloride, CH2Cl. Then definitely they have added this one and CH3. MgCl, Grignard region. Then this kind of a tertiary alkyl halide was there. So that this is alcohol, tertiary alcohol. Probably here they have CH3 OMGBr, CH3, CH3. Then this one should be probably CH3, C double bond or CH3, acetone, O2 propanol, right? So this is the third one. And how about the fourth one? Fourth one should be CH3, CH2Cl. And here we have to magnesium, right? And here we can say that CH3, OMgCl, CH2, CH3. H3 plus means here we can say CH3OH, CH2, CH3, PCl5, CH3, CCl. In this way. So raise your hand who completed the third one and fourth one quickly. Raise your hand quickly. Huh? Quickly write down these two. I'm going to give you two conversions. So you have to do them as a homework. If you want, you can do that one and send me the answers today itself. You can, right? Quickly complete this one. As a homework, do these two reactions. Soon after the class, I'll send you this one as a conversions of the day. But you can write down this one now. 3 steps only. And the second one, how many steps I can give you for this one? Not more than in 7 steps. Don't be panic. Maximum 7 steps. You just think and do this one. CH2, CH2. So do them as a homework. So quickly complete the fourth one. Now we have to go for the next reaction. So that next reaction is very, very important. Quickly. Right, okay. Are we done? Shall we move to the next reaction? Yes. Now let's move to the special conversion reaction number 3. Okay. I'm going to erase this one. Now. Special conversion reaction number 3 is very, very important. This is addition of water for the alkynes, right? Addition of water for alkynes. If not, we can say that hydrolysis of alkynes. Special conversion reactions number 3. We can say that addition of water to alkynes. Can write down here hydrolysis of alkynes. Right. So this is a very interesting reaction. Here the Markovnikov rule is also added. And I remember Markovnikov. Right. Now listen to this one carefully. Yeah. Students, first of all, I'll teach you the short method that relevant to write down the reaction product later. First of all, I'll explain what will happen exactly. Okay. So let me take the simple alkyne in this way. So this is the ethyl carbon triple bond. This is ethyl simple bond. In order to do the hydrolysis reaction here, if not addition of water to alkyne, so here we are adding exactly a catalyst like mercury, Hg2 plus. Right, this reaction is only taking place in between this with this Hg2 plus mercuric cation. Right. So in previous syllabus we learn mercury sulfate, diluted sulfuric, along with the temperature 60 degrees Celsius in all syllabus before 2017. That means when we are doing A level, actually we learn in this way. But now in your resource book, they have clearly mentioned that just enough Hg2 plus. That means any kind of mercury salt, mercury sulfate like, mercury nitrate like salt. In the presence of H plus H2O, right? H plus H2O, not dilute sulfuric. If they haven't given these conditions H plus H2O, then you can use what? Dilute sulfuric, right? Maybe I think they wanted to show here the water molecule is participating in the reaction. That's why. Okay. So what will happen here, students? Here, water molecule is actually reacting with this alkyne. We know that in water molecule, hydrogen and OH is there. So hydrogen is coming towards one carbon atom and OH is coming towards another carbon atom and the bonds are breaking. Here, in the triple bond, only one bond is breaking. One hydrogen is connecting to carbon, OH group is connecting to the other. Then you can see this kind of a product, right? This product is very interesting. Double bond, OH, H, right? So let's revise the isomerism theories also. This is alkene. Tell me, students, is this molecule showing the diastereomerism? Geometrical isomerism? No. Right? Why? What is the reason? I told you that in order to show the geometrical isomerism, in order to show the diastereomerism, carbon-carbon double bond should be there. Each carbon atom should be connected to different carbon atoms. So therefore, this carbon is not connected to different carbon atoms. This compound is not showing the diastereomerism. Okay? Isomerism theories. Right. Anyhow, now this is the product. This is the first product that we obtain when we add water for the alkyne in the presence of the catalyst Hg2 plus. Students, remember, in this compound, can you observe a double bond? Right? So what is the scientific term that we are using to denote a double bond? What is the scientific name that we are using for the double bond? Ene. Alkene ene. IUPAC suffix in. What is the IUPAC suffix I taught you to write down for OH group? What is it? Ol. In plus ol. This compound is known as enol. Enol. I can't exactly remember the year. In very recent past paper, they have given MCQ, right? One MCQ, 2023 or 2022 maybe. I can't exactly remember. Okay, enol. This enol product. So when we add water for alkyne, what will happen first of all? This enol product is formed, right? But remember, students, this enol product is very unstable. Can you understand? Like unstable. Because double bond, there is a double bond here, and here we have OH group. So oxygen is also pulling electrons. So existence of this double bond and OH group is not stable. This compound is very unstable. So since this is very unstable, this molecule is rearranging. This molecule is rearranging into this kind of a compound. Look at this. So now this is the compound that we derived. I will teach this one in theories as the reaction mechanism properly in detail. Now here I'm going to discuss only the background area that we need to discuss the reaction. Okay. In theories, let's learn the proper thing. Now, so this is rearrangement. I'll tell you how to write down the rearrangement, the bonds breaking and everything under the theories when we learn the reaction mechanism. And others also, don't worry, since I'm uploading the reaction mechanism, you can see that one. Okay, right. Now, in the rearrangement, what will happen is one of the hydrogen, now OH group is there. This OH group is breaking, hydrogen is going for the other carbon atom by breaking this double bond. That means this double bond is shifting to the carbon oxygen and making this kind of a compound. So what is this? So this aldehyde. That means we can consider that since the enol group is unstable, it has been converted into an aldehyde. Sometimes you can obtain the ketones as well. Students, remember, what I want to teach you here is the first product that we obtain by addition of the water for the alkynes is not a ketone or aldehyde, right? Because some of the students are thinking that when we add water molecules for the alkyne, directly they are converting into aldehyde and ketone. It's not like that. So there will be an intermediate reaction. There will be intermediate product that is enol. But remember, this enol is unstable. Since it is unstable, it is rearranging. After the rearrangement, only it will be converted into aldehyde or ketone. Got it? That's what happened. So keep that in your mind. Let's learn this one properly again in the theories. Right? Now, can you get the idea? Please raise your hand. Raise your hand who got the idea simply. What happened exactly? Right, good. So that is not important for the reaction. Huh? That is not the important for the reaction I'm going to teach you, but I wanted to discuss this one here. We can't skip this one because the first reaction is taking place here is this one, production of enol, right? Put note and write down this one quick. Note and write down this one. Note kar takal liya. Done, eh? Right. Now, students, let's go for directly the reaction. Now let's see what is how to obtain the final product directly. Okay, that's what important for the reactions. That's what important for the conversions. Now let me consider the same example that we discussed. Alkyne is there, ethyne. For ethyne, we are going to add H plus H2O as a catalyst. We are going to add mercuric cation, any mercuric cation containing salt. Right? So here, water molecule, right? So now I told you under that enol product, water molecule should be separated into OH and H, right? So here, what I'm going to do here is, I'm going to separate that water molecule in this way, oxygen and hydrogen. Oxygen and two hydrogen. Then what you have to do is, you have to connect this oxygen for the one of the carbon atoms and two hydrogens for the remaining carbon atom. Then you can see hydrogen, carbon, oxygen, double bond. Always you have to connect that oxygen to the carbon atom through a double bond and CH3. Now you can clearly see we have produced an aldehyde, right? We have started from alkyne. Now we have produced aldehyde, right? In some cases, actually, we will obtain what? Ketones as well, right? So this is the reaction. So rather than going for that enol and everything, you can directly take one oxygen and hydrogen. So this is the case where we have a symmetrical alkyne. If we have asymmetrical alkyne in this way, CH3, C triple bond, CH under. Then මේ වගේ වෙලාවකදී, so to which carbon atom we have to put hydrogen, to which carbon atom we have to add oxygen. අන්න එතකොට කාවද ගේන්න ඕනේ. Right? So which person that you have to recall? Which person you have to call? Huh? Markovnikov. Last week we learned Markovnikov rule, right? Markovnikov's rule, right? Simply, what did I teach you to remember the Markovnikov rule? Simply, what did I teach you? The rich get richer, right? Remember, students, Markovnikov rule says that the rich gets richer, more richer. The rich get richer, right? And we learn Zaitsev rule is what? The poor get poorer. Zaitsev means releasing, removing hydrogen. Markovnikov saying that addition of hydrogen, right? Remember, when there is asymmetrical carbon-carbon double bond or carbon-carbon triple bond, always the hydrogen should be added to the carbon atom who is rich with hydrogen. That's why I consider the rich get richer. Markovnikov rule, remember students, those who don't know this one, Markovnikov rule simply says that the carbon atom who is already rich with hydrogen atom is taking hydrogen when we add compound, right? So the rich get richer means here now when you consider this carbon atom, number 1 and number 2, tell me who is rich with hydrogen? Second one, right? The first one is only connected to alkyl group like CH3, but the second atom already there is a hydrogen. So therefore we can say that this is the carbon atom who is rich with hydrogen. That rich carbon atom is again becoming rich when this water molecule is added. So try to understand here, hydrogen should be connected to this carbon atom, while oxygen should be connected to the other carbon atom. Markovnikov, huh? You have to follow the Markovnikov. So then the product should be CH3, C double bondo, CH3. Now tell me, we have started from an alkyne and we have ended up with ketone. Okay? That's why I told you, not only the aldehyde product, sometimes we have to obtain ketone product as well. Okay, Nether? Quickly write down. Always keep that in your mind. Hydrogen should be connected to the carbon atom who is rich with carbon, who is rich with hydrogen. Quickly. Right, okay. Are we done? Yeah. Now let's discuss few examples. Let's discuss few examples on this reaction. So we can say that hydrogens are connecting here, oxygen is connecting here in this way. So this is a symmetrical alkyne. So therefore nothing to worry. Second one, now you can see that this is a symmetrical one. So here we have two carbon atoms. So tell me who is rich with hydrogen? Left hand side carbon atom, right? So therefore the hydrogen atom should be connected to that carbon atom. Then CH3, C double bond O, CH3. Acetone is produced. That's very easy. We can learn the theoretical background, how the bonds are breaking and everything in the theories. Don't worry. Here you just learn the reaction, that's all. Okay. Then look at this one. CH3, CH2, C triple bond, CCH3. What do you think about this one? Hmm? So here, both the carbon atoms are not containing hydrogen. Then both the carbon atoms are not connected to hydrogen. Then how do you decide that hydrogen should be connected to which carbon atom? Neighbor, look at the neighbor, right? So who is the neighbor of this carbon? This one, 2 hydrogen, and here 3 hydrogen. Then hydrogen should be connected to this one, right? That's the way that we are applying Markovnikov rule. Remember, if the 2 carbon atoms that connected through a double bond or triple bond not containing hydrogen, any of them, look at the neighbors. So the neighboring carbon atom of this one is this one. There are 2 hydrogens. Neighboring carbon atom for the right hand side one is this one, 3 hydrogen. Then rich get richer. So therefore, you can put your hydrogens. Number 4. In the number 4, try to go for the reverse. The product is given. The product is given like this. So the product is CH3, C double bond O, CH2, CH3. So how do you obtain the reactant? Number 4. So students, definitely we know that this is one of the carbon atom containing the triple bond, no doubt about it. Then we have to choose the other carbon atom, right? We know that triple bond carbon atom breaking the bonds and oxygen should be connected to that carbon. Then, so this is one of the triple bond carbon atoms we have. Then the remaining carbon atom should be the left hand side one or right hand side. We know that according to the Markovnikov rule, hydrogens are added to the carbon atom who is rich with hydrogen. So which carbon atom can be that rich? Who is rich carbon atom? This one or this one? This one. Then the triple bond other carbon atom should be this one. Then carbon triple bond. See here CH2 CH3. Now you can understand that one. That's correct. The way that we took the decision is correct, because according to the Markovnikov rule, we know that when we are breaking this triple bond, oxygen should be added to the hydrogen should be added to the carbon atom who is already rich with hydrogen. Then left hand side, right hand side, then this is the carbon atom who is rich with hydrogen. Neither. Then oxygen, hydrogen here, oxygen here. So the reverse thinking is very important. Okay. Number 5. What should be the answer? Definitely, this carbon atom is the triple bond carbon. And when you consider the neighboring carbon atoms, the other adjacent carbon atoms, this is the carbon who is rich with hydrogen. Then this one should be the carbon who contain triple bond. Now you can understand the importance of Markovnikov rule we learned in the last theory class. I taught you, I explained you that one perfectly. Now these are the applications of the Markovnikov. Number 5. Number 6. What about 6 and 7? So nothing different, the same thing. You can say that in this way. And here this is not containing hydrogen. Then the triple bond should be in between these two carbons. Number 7 is look like this. Quickly complete this. Right, okay. Are we done? Right. Okay, students, you have another homework. Do this conversion also. not more than in 4 steps. Okay. You have to do this conversion not more than in 4 steps. So there are 3 conversions. So let's see who are going to send me the answers, correct answers. Not more than in 4 steps. Yes, you can do that one. So today we learn, I think, 3 new reactions, and last class we discussed 2 reactions. Now 5 reactions are in your hand. So use them and do the conversion. Okay, right. Okay. So students, how was the today's session? Is everything clear? Please raise your hand. Is everything clear? Please raise your hand who understood the things that we discussed today. So next Wednesday also we are going to do some new reactions, new conversions will be there, right? So do these conversions. මේ reaction මේ conversions ටික කරලා මට උත්තර ටික එවන්න. මම හැම Sunday every Sunday I'm going to upload the answers. So before that you try, okay? Better you try these 3 conversions soon after the class. Sometimes you won't spend there at least 5 minutes to do these 3 conversions. විනාඩි 5ක්වත් යන්නේ නැහැ හරි. අප ගාලා ඉවරක් කළා දාන්න. Right, okay. Students, then let's meet on the Friday paper class, and Saturday we have the theory class. If you don't have any doubts, do you have any doubts? Anything? Everything is crystal clear. Good. Right, okay. Then let's meet on the Friday paper class. Until then, bye bye. Have fun. Good night for all of you. That will be see you.